Alright guys, so today's notes are all about slope again, and then we're also going to use that slope to then graph. Okay, so linear relations. When points on a graph lie along a straight line, it is called a linear relation. Linear relations can be represented by an equation. For example, the equation of this graph on the right can be written as x plus y equals 8. Linear relations are often written in standard form. Standard form consists of a, which is an integer, multiplied by x, which is a variable, plus b, which is an integer, multiplied by y, which is another variable, and it's equal to c, which is an integer. So it says that a has to be greater than or equal to 1, and the greatest common factor of a, b, c is 1. So what does that mean? And a good example to use is this. If a was 5, so it would be 5x plus b, we would use 10y, equals c is 21. This is a good example of a standard form linear equation. An example of not standard form linear equation would be this. 5x plus 10y, 10y is equal to 20. Why is this not a good example of standard form? Because the greatest common factor of all of these things is not 1. So you could divide 5 out of every single one of these. So therefore, it's not in standard form. Okay, so standard form has to have a greatest common factor of 1. Alright, so this says write each equation in standard form. Okay, so if you're writing these equations in standard form, you have to remember a must be greater than or equal to 1, greatest common factor has to be 1, and they all have to be integers. Integers means either negative whole numbers or positive whole numbers. Okay, so then let's go through this. So right here we have a value that's not greater than 1, okay? So then it says write each equation in its standard form. So then we have to make this a value become 1, right? So if we multiply the left side by negative 1, and we multiply the right side by negative 1, now we have positive 5x minus 6y is equal to positive 12, okay? And then the greatest common factor of all of these is 1, and now they're all integers, greater, and then a is greater than or equal to 1. Okay, now let's look at this one. So this one's not in standard form because, well, the x and the y are on two different sides. Okay, so let's move those to the same side. I'm going to move y over, so if I subtract y from both sides, now we have 0 is equal to 2x minus y minus 9, and then we add the 9 over. Okay, so we get 9 is equal to 2x minus y. And, you know, this is normally on the left side, this is on the right side. This is okay standard form, but if you wanted to rewrite it, you could. 2x minus y is equal to 9. Okay? And by all means, guys, you could have subtracted y and added 9 all in the same step. I'm just going to go step by step to make sure you guys are seeing everything in every problem. Okay? Taking a look at this next one. Okay, if we're looking at the next one here, we have negative 24, 9, and 6, so we got to move that 24 over. So we have 9x plus 6y is equal to 24. Okay, and then it looks like there's a greatest common factor that comes out of all of these. So if we divide everything by 3, that would give us 3x plus 2y is equal to 8. And then bam. Now we have that. Alright, so hopefully you're getting the idea of converting these into standard form. You could pause here and try 4, 5, and 6 on your own just for some of your own practice. Or I'll just keep going and just kind of go quickly through these last couple. Okay, so here I'm adding 7x to both sides. So we get 7x plus 7y is equal to 7. 7 comes out of all of these things, right? So divide everything by 7. And then we get x plus y equals 1. Okay, so there's two different ways to write everything divided by. As you saw in 3, I wrote each singular thing. As you saw in 4, I wrote every single thing under divided by 7. All right, next one. Okay, so we don't have, these are not integers, those are fractions. Okay, so we have to get rid of fractions. Well, when there are two different numbers in the bottom, we learned this when we were solving equations, you have to multiply by the greatest common or least common denominator. Right, least common denominator in this sense is going to be 12. If you just multiply those two numbers together. So then we're going to take 12 and multiply it by the left side. If we do it to the left side, we also have to do it to the right side. So multiply the right side by 12. That's going to give us 9x minus 4y is equal to 12. And then the greatest common factor between all of those is 1, so we're done. And then the last one here, okay, I'm going to subtract the y over, so we get 1/6 x minus y equals negative 2. And then multiply everything by 6. So that's x minus 6y equals negative 12. All right. For those of you who tried them on your own, if you want to check your answers real fast, there they are. All right, let's keep going. Linear equations are often written in slope-intercept form. Okay, so what is slope-intercept form? This is when this is probably what you've seen over and over again. Y equals mx plus b, where m is the slope and b is the y-intercept. Okay. Slope is a constant rate of change between points. Think rise over run. There are blank types of slopes. Sketch them below. So 4 empty slots, we have 4 different slopes. We talked about these on Friday, so hopefully you remember. We have positive slopes. We have negative slopes. We have slopes that are 0, so a 0 slope or no slope. And then we have undefined slopes. So let's sketch all these. Positive goes up from left to right. Negative goes down from left to right. A 0 slope is a horizontal line. And an undefined slope is a vertical line. Okay, so those are our 4 different types of slope. So now let's get into it. It says write the equation in slope-intercept form, then graph the line. Okay, so let's take a look at 7 here. 7 says the y-intercept is 7, so that means 1, 2, 3, 4, 5, 6, 7 on our graph. We go to 7, and then the slope is going to rise 2, and it's going to run 5. So if we were going to the right, we would go up 2. Well, it kind of takes us off the graph there. So if we want to go the opposite direction, we go down 2, and then instead of running to the right 5, we run 1, 2, 3, 4, 5 to the left. You know your graph is going the right way based on your slope. Right, the slope here is positive, and is our graph positive? Yes, because it's going up from left to right. So then we're good. All right, number 8. So if you've never seen this symbol before, it's called function of symbol, okay, or f of x is what you'll normally hear me say. This is the same exact thing as y. So a lot of times I'll write f of x because for me, I like that notation better. But if it confuses you, you can just replace it with y for now. But I definitely recommend starting to learn that f of x is just y. Okay, so like you could replace f of x and just say y equals x plus 2. But I would be learning that f of x is just another way of saying y. So the y-intercept here is positive 2, so we go up 2. Slope here is 1 over 1, right? So that means we're going up 1 to the right 1. And then we can draw our graph through those points. And again, it's a positive slope, so our graph should look positive, and in this case, it does, right? It's going up from left to right. All right, if you're doing okay graphing, again, try these two guys. Try 9 and 10 on your own, and then come back. Remember, you might have to put them into slope-intercept form, but I will go through them quickly if you're still struggling with this stuff, okay? So subtract x from both sides, you get 3y is equal to negative x minus 15. Divide by 3, divide the right side by 3. When you're writing slope-intercept form, you have to split this denominator up into its 2 separate parts. Okay, so that's negative 1 over 3x minus 15 over 3. Right, so then if we simplify, that's negative 1/3 x minus 5. And by all means, guys, you do not need to put as many steps as I am. I'm just doing it to show you every single little detail of the math right now. So down 5, 1, 2, 3, 4, 5, graph it. And then now the slope is down 1, right 3. 1, 2, 3. Or we could go up 1, left 3. So up 1, 1, 2, 3. And again, the slope is negative here. So then you should, whoops, sorry, keep trying to write sideways and it shifts on me there. So then the slope is negative, so then you should be going down from left to right instead of up from left to right. And it looks like that is a negative slope. All right, number 10, last one here in this group. Add 5x to both sides. Now we have 10y equals 5x plus 20. Divide by 10. Y is equal to 1/2 x plus 2. So we go up 2, and then we go, the slope is up 1 to the right 2, just like that. And then if we graph it, it should go something like, nope, not shallow enough. Down 1, left 2 would be right there. So then we graph this. Maybe, yeah, that's close enough. All right, bam. Just like that. Okay. So 9 and 10 we had to change to slope-intercept form. But yeah, hopefully not too hard, and you guys have done that before. All right, vertical and horizontal lines. Write the equation for each line shown on the graph, right? So vertical line, all of the x values are going to be the same on a vertical line. So if we look at this, 1, 2, 3, x equals negative 3, okay? So then the graph for this line, or the equation for this line, is actually just the equation x equals negative 3, because it doesn't matter what y you plug in, every single x value is going to be negative 3. Okay, so we would just say x is negative 3 for a vertical line. For any vertical line, it's just x equals whatever value is there. Okay, so that's all vertical lines. Horizontal lines are actually super similar, right? But the slope is 0. So think about this. Well, if we had y equals 0m, well, what's the only thing that goes on in slope-intercept form? Or y equals 0x, because 0 is the slope here. Right, so then what's the only thing we have left? Well, we just have plus b. Well, b is the y-intercept, so we just say, okay, well, at the y-intercept, that's all I'm going to have for this equation. So we have 1, so then y is equal to 1. Okay, because no matter what x value you plug in, whether it's 1, 2, 3, 4, negative 1, negative 2, your y value is still just 1. Okay, so the y is equal to 1 for any type of horizontal, for this specific horizontal graph, but for anyone, it's just whatever value you go through the y-intercept at, or whatever y value you see the graph at, okay? All right, almost done here. Determine whether the pair of lines are parallel, perpendicular, or neither. Remember, parallel means same slope, perpendicular means opposite reciprocal, and then neither would just mean that the slopes are just completely different. They have no commonalities between them. Okay, so to determine slopes, you're going to have to put them into slope-intercept form, okay, or just figure out the slope. You just need to get as far as you need to know what the slope is going to be. So I'm subtracting 10x from both sides, seeing 5y is equal to negative 10x plus 5. You divide the 5. Okay, so we get y is equal to negative 2x plus 1. Well, we have negative 2 there. Let's see what we have on the other side. So if we have negative x, we're subtracting 16, so minus 16 equals 2y. Divide by 2, so that's negative 1/2 x minus 8 equals y. So we have negative 1/2, we have negative 2. Well, it's an opposite, but it's not an opposite, it's just a reciprocal, right? So it's 2 to 1 over 1/2, but they're not opposite signs, they're the same signs, so this is neither. Okay. 14, we're going to subtract the 8x, and then we have negative 6y equals negative 8x plus 42. Divide negative 6. Right, so then we have, for a slope, we're going to have negative 8 over negative 6. That simplifies down to 4 over 3. Okay, let's look at this one. So divide by -3 to everything. So the slope on this side is going to be 4/3. Well, these two slopes are equal to each other, so then they must be parallel lines. All right, let's look at 15. So 15 here, I'm going to add the 8x over to the other side. We have 8y is equal to 8x. So we get y is equal to 1 when we divide, 1x. Let's look here. We have, I'm going to add the y over, yeah. We get x is equal to y plus 4. And as we can see, x is by itself. Okay, so the slope on this one is also 1. So the slopes here are going to match each other. So then they are parallel again. And then the last one here, okay, well, x is equal to 2 and y is equal to 2. So then if we actually graph this, right, x is going to be 1, 2. Y is going to be 1, 2. Well, where a horizontal line meets a vertical line, it is perpendicular. Another way to tell, guys, is because the slope here is equal to 0. How do we get this slope? Well, when we actually do this a little bit later, we'll see that anything divided by 0 turns out to be undefined. And right, the slope of this graph is undefined. Okay, so it's sort of a reciprocal. It's sort of a reciprocal here because we're dividing by 0 for x equals 2, and the slope of y equals 2 is 0. So they're sort of reciprocals, but yeah, we're going to go into more detail with that when we actually talk more about dividing by 0. But just know that horizontal line is always perpendicular to a vertical line. Okay, last question here. So, you and a friend kayak 1,800 yards down a river. You drift with the current partway at 30 yards per minute and paddle partway at 90 yards per minute. The trip is modeled by this equation, where x is the drifting time and y is the paddling time, both in minutes. Find the x and y intercepts, graph the equation using the intercepts, and then what do the x and y intercepts represent in terms of this scenario? So, to find an x-intercept, all you're going to do is plug in 0 for y. So plug in 0, instead of writing the word 0, plug in 0 for y. So then that means to find the y-intercept, well, guess what? You just plug in 0 for x. Okay, so then let's do that real fast. So we have 30 x plus 90 times 0 is equal to 1,800. So then that's going to give us 30x is equal to 1,800. So then we divide by 30. That's going to be 180 divided by 3. So x equals 60. For the x-intercept, this is our x-intercept. For the y-intercept, we would do 30 times 0 plus 90. Y equals 1,800. So that's 90y is equal to 1,800. Divide by 90 on both sides. Y is equal to 20. Right, and then that is our y-intercept. Okay, so these are our two intercepts. X equals 60, y equals 20. So then let's graph that. So then we have, I'm going to count by tens. 10, 20, 30, 40, 50, 60, 10, 20, 30, 40. So our y-intercept is 20, so then we go up to 20. Our x-intercept is 60, 10, 20, 30, 40, 50, 60. And then to graph that, we're just connecting those two dots. Okay, so boom to boom. That's our graph. Okay, if you want to get real fancy, now let's talk about what our x and y intercepts represent in terms of this scenario. Well, it's saying that 30 yards per minute is paddling, or that's just drifting, right? Drift is 30 yards per minute. Paddling is 90 yards per minute. So our x-intercept, when we plugged in 0 into this part of the equation, that means we paddled for 0 minutes. So then our x-intercept is the time if we don't paddle at all. while the y-intercept is the time if we paddle the whole time. If we paddle the whole way. Okay, and that's because if we plugged in 0 for x, right, if we drifted for 0 minutes, then that means we paddled the whole time for 20 minutes, okay? So this question is, if you paddle for 5 minutes, what is the total trip time? So then we're going to plug in 5 into the paddling time to see what we would get out. So 30x, we don't know how long we drifted for. So 30x plus 90 times 5, because that's how long we paddled for, equals 1800, right? So then that's going to be 30x plus 450 equals 1800. Okay, so then we subtract 450 from both sides. Sorry, this is getting kind of small. So 30x equals, that's going to be 1350, right? 400, yeah, 1350. And then if we take 1350 and we divide by 30, so 1350 divided by 30, that's going to give us 45, so divide by 30 here. We get x is equal to 45 minutes. But it asks us what is the total trip time. Well, we can't forget about those 5 minutes that we first started paddling. So then we have to say the total trip time is 50 minutes. So if you paddle and drift equal amounts of time, what is the total trip time? So this question, a little bit more challenging, okay? But if we paddle and drift the same exact amount of time, what does that tell us about our variable? Well, if x and y talk about time drifting and paddling, if it's the exact same, then we can just use the same variable twice in a row. So we can say 30x plus 90x is equal to 1800. Okay, so because of the times are the same, we just use the same variable because that number is going to be the same in our final answer. So 30 plus 90 is 120x equals 1800. Divide by 120 from both sides. So 1800 divided by 120 gives us 15. So x is equal to 15 minutes. So the total trip time then would be, well, 15 minutes is what we're doing for one of them, right? Because we only solved for one x. So 30 minutes is the total trip time because we spent 15 minutes drifting and then 15 minutes paddling. Okay. So I hope these notes went okay. I know they were a little bit longer, but now that we're in hybrid, I figured you guys could handle a little bit longer notes since you aren't in class at all. Please, please, please come with your questions tomorrow, okay?